yesterday you learned a little bit about finding denominators that are the same so that we can add fractions, okay? Today we're going to continue practicing that, but we're going to practice it on paper. So the first thing I need you to do is give me 2 area models underneath your first problem A. Okay? And we're going to start by reviewing what we learned yesterday and talk our way through these. Okay? And I'm going to try not to say okay so often. That's going to be my goal, because I say it way too much. So I'll change it to all right. The first one shows 1/2. So how many equal parts do I need in the first area model? Just tell me. 2. Okay. And the first one, we're going to use vertical lines. How many parts will I shade? 1 part. Below your area model, this is very important. Go ahead and write 1/2, okay? I'm recording, just so you know. I did. The second area model, how many equal parts do I need? 3. So that means draw 2 lines. Which way? Horizontal. If you don't draw the lines horizontal, then you can't combine to get a new denominator. So here is what I need to do on the second area model. How many parts will I shade? 1 part. So this shows 1/3. The first one shows 1/2. Raise your hand if you remember that little trick you can use with your 2 denominators to come up with a new denominator. Jesus? Okay, I'm going to combine the lines on my 2 area models. But there's a way to do it without an area model. Do you remember that, Modesto? Multiply. So if I multiply 2 times 3, what do I get?
6.
That's going to be my new denominator. Now, Jesus is right. If I combine my shapes, how many equal parts do I have now? 6. So that little trick works, doesn't it?
Yes.
So now take your horizontal lines and add them to your first area model. Add your vertical line to your second area model. This is where the kids got a little confused from the morning. How do I figure out my new numerator? Abrielle?
You look at the boxes that are shaded.
Okay, so how many boxes are shaded on the first area model? 3. How many are shaded on the second?
2.
Back up here beside the problem, rewrite the problem with the new numerators and denominators. And add your numerators. There's my answer. Can this be simplified? No. Most of the time when you see a fraction and the numbers are just 1 number apart, you can't simplify it. Okay? Let's go on to the next one. I bet you wish you could make an area model as good as mine. It's not fair, is it? Well, I'm using technology to my advantage.
What if you put those pictures on our
That would be so awesome.
computers?
If you put those boxes on here.
Before I start drawing my horizontal lines, I want to think about how many lines will I need
3.
in this second area model.
4.
4 lines, okay? It's going to be 5 spaces or 5 parts.
Yeah.
Do you remember the word partition? We used it quite a bit in 3rd grade.
I remember it, but I don't know what it means.
Now, partition means to divide your shape, okay? Like if I were building a house, my walls would partition the walls would partition the floor.
Roof.
So that the walls will divide the rooms into different sizes, okay? And so that's what we're doing with the area models. We're partitioning them I'm using the denominator to help me decide how to partition. Okay, help me out here. What's that strategy I can use to figure out a new denominator, Nicole?
Add the line.
I could, but I want to multiply the denominators. So what will my new denominator be?
15.
How do you know?
3 times 5.
3 times 5 is 15.
Oh,
Good.
yeah.
Now, let's add horizontal lines to the first area model. And you got to make sure you got the exact same number. And add vertical lines to the second area model. Now, both shapes, or both area models should have how many equal pieces?
15.
15. How many are shaded in the first one? How many are shaded in the second one?
3.
So I'm going to rewrite 5/15 plus 3/15, and that gives me 8/15. Do 8 and 15 share a factor?
Joe.
No, they don't. 8 has 4 and 2, and 15 has 5 and 3. So this is simplified. Okay. For C and D, we're going to do the same thing. Draw a couple area models. All right, I'm going to start calling on people. Sebastian,
What is that?
how many equal parts do I need in my first area model? 4. So how many lines would that be? Oh my goodness, you're like a step ahead of me. How many will I shade here? Sebastian, how many will I shade?
1.
Okay, good. So the next area model, Channing, how many equal parts will I need? And which way will my lines go? Horizontal. How many will I shade?
1.
Okay. So 1/4 plus 1/3. If I use the strategy of multiplying my denominators to get the new denominator, what's my new denominator going to be? Ethan?
4.
4 times 3.
12.
Okay, so my new denominator is 12. Go ahead and add horizontal lines and vertical lines. Make sure you count the spaces. So this one becomes 3/12. Second one becomes 4/12. Rewrite the fractions, 3/12 plus 4/12. Okay, Christian, I'm going to ask you, how do you know immediately that you can't simplify this fraction?
Because nothing goes into 7.
You're right. What's that number 7
Prime
called?
number.
A prime number. My goodness, you guys remember. They didn't remember the word prime this morning. Somebody remembered it started with a P. 7, if I wrote the factors for 7,
1 and 7.
the only ones are 1 and that number. Then it's considered a prime number. And you know you can't simplify it. That's right.
On 12, you do like 6 times.
Yeah.
What's the other one?
Well, we'll get, this is the one we talked about this morning.
I know, but the opposite of prime.
Composite?
Yeah.
Okay. Let's do the next one, and then on the back, we're going to kick it up just a notch. So, who has not helped me?
Me.
Okay, George, how many equal pieces do I need in my second area model? Because you're right. So how many lines would that be?
6.
Okay, how many do I shade, George? 1. Now, this part is very specific. You need to start from the bottom when you're shading the horizontal sections. Do not start at the top. You'll find out in a few lessons, okay? So who knows, Elena, do you know the new denominator?
Yes.
What is it?
21.
How'd you figure that out?
I multiplied 3 times 7.
You're right. And when I combine my shapes, isn't that what I'm doing, multiplying? Yes. Now, it's kind of hard to draw 7 lines again, so do you know I use this little trick of lining it up with the one right beside it?
Nope.
1, 2, 3, 4, 5, 6, 7.
Actually, you have 7 lines.
No,
6 lines.
6 lines. Sorry, I said that wrong. So here's what I have for my 2 new fractions.
Yes.
Now, it looks to me like I might be able to simplify 10 21s,
You can't,
but I can't. Why not?
because 10's an even and 21 is an odd.
Very good. Now, sometimes that's not
It's a problem.
That's not why, but that's why this time. 10 doesn't have a factor of 3 or 7, and 21 does. So they don't share any factors except 1. That's not going to do us any good.
No.
Okay, let's keep going. Now these are a little bit more difficult.
No.
Finally.
What kind of
Okay. Oh, there I go again. So this is a little different. Rayleigh, tell me what to do on the first area model. So 4 spaces or 4 equal parts, 3 lines, and how many are shaded this time? So the numerator's what's different, isn't it?
Yeah.
Okay. Marlene, how many equal parts do I need on the second area model?
4?
4 lines, how many equal parts?
5.
5. How many are shaded?
1.
Okay, now who has figured out the new denominator? Okay, somebody have, Lily,
20.
you're right. How'd you get 20?
10 is 4 times 5 is
Good. Now when I add horizontal lines to my first area model, gotta be careful when you count these. Here's what someone in block 1 did. Eyes up here for just a minute. They went 1, 2, 3, 4, 5, and then they stopped, and they wrote a 5 here.
No.
No.
I count all the shaded areas.
Gotta count all the shaded boxes. That's why you can't do complete shading, because it's too hard to count your boxes. So I have more than 5. How many do I have?
15.
15. Now, all of the mistakes that I've seen so far today on the exit ticket have been the numerators.
Oh, yeah.
Okay? All right, 15 20ths plus 4 20ths equals,
19.
and how do I know that's already simplified?
Because
Griffin,
Guys, 19 doesn't have any.
19's a prime number.
And 20 is has been in 19 and we don't have any other simple.
Good. And then I remember I gave you that little hint. If your numbers are just one number apart most of the time, it's already simplified. Okay? Let's go on to the next one. Griffin, you haven't helped me yet. How many equal parts do I need in the first area model? 3. Right. How many are shaded?
2.
Okay. So 2/3. And then the next one, Christian, how many equal parts do I need?
6.
6 lines, 7 equal parts. How many are shaded?
2.
Okay. Christopher, what's my new denominator?
21.
How'd you get that?
By multiplying 3 times 7.
Good. Okay. are shaded in the first area model? I have 14. Is that what you have?
Yeah.
Okay. How many are shaded in the second area model?
6.
So rewriting this, it's pretty important to rewrite it, boys and girls. So make sure you rewrite it and that you're not being lazy and just writing the answer. Can this be simplified?
No.
No.
Answer's hard to say 2021.
I know. Now we talked about in block 1. Should I be saying 21st?
No.
No, that doesn't make any sense either. So 2021s. Okay, let's look at the last problem. Yeah. This one is going to be a little bit trickier. And I knew that right away because of this last sentence. It says, solve the following problems. Draw a picture and write a number sentence that proves the answer. Simplify your answer if possible. So that tells me I might actually have to simplify, okay? Which we really like to do. Okay, here is the question. Jamal used 1/3 yard of ribbon to tie a package and 1/6 yard of ribbon to tie a bow. How many yards of ribbon did Jamal use? Now it says write a number sentence. So let's do that first. What does my number sentence need to include?
Numbers.
1/3 plus 1/6. This time it's not only numbers, it's fractions, isn't it?
Yeah.
Now I'm going to show 1/3 on the first area model.
2 lines, 3 equal parts.
Okay,
Any one of them.
please don't do that. Go ahead and rewrite 1/3 down here. I want you to get in the habit of this. Now, real quick, I want to remind you what it's going to look like if I do this wrong.
You can't understand it.
Look at this, because I did have a student do this on their exit ticket. If I try and combine these shapes, and I did all vertical lines, does that make any sense to you? No. So that's the reason for the horizontal lines.
Horizontal.
Right.
Shade 1 on the second one.
And shade 1 out of 6. Okay, now if I multiply 3 times 6, what number do I get? 18. That's my new denominator. According to the strategy we've been using, which is multiplying denominators to come up with a new denominator, okay? And when I combine I have 6/18 and 3/18. Is that what you got?
Yes.
So 6/18 plus 3/18 equals 9/18. Now stop just a minute, because I want everyone to have to think this through. Just wait to tell me, okay? What strategy did we use yesterday to figure out what factor two numbers share?
Nice.
We put them on the T-chart, didn't we? Okay, so watch this. This is so cool. 1 times 9, 3 times 3, right?
Let's simplify it.
1 times 18, 2 times, 3 times. Okay, now in block 1, somebody said, oh, I know what you do, Mrs. Liz. You're going to divide both of them by 3 because they both share 3.
They both share 9.
Is that true, though?
They both share 9.
Why is 9 better?
Because it's larger and it's your numerator.
It's larger. Very good. What's the first thing I told you to check when simplifying problems?
Your numerator and denominator.
Does the numerator divide into the denominator? So we will divide both of these by 9. And the answer is 1/2. Because 18 divided by 9 equals 2.
Just because they're positive.